Okay, so let's get started. We're going to be taking a look at setting up and working with our drive-by-wire idle control. The last few tutorials, we've went through the setup and configuration in the background for the drive-by-wire to work correctly as we're driving. So we've set up our PID gains, we've set up our min-max clamp, our feed-forward table, and our throttle target table. Now, all that really applies to when the car is driving, so specifically the target table. Now we're interested in setting everything up for our idle control. All of the background work is already taken care of. So again, the PID tuning, the feed forward table, that's been established so the link can control the throttle plate opening and do that in a precise manner. Now we can turn our attention on to setting up our idle control with drive-by-wire. Now we've had a couple tutorials talking about setting up and working with idle control for a stepper and a pulse width modulated solenoid, as well as a mechanical based idle control that's applying to something like individual throttle bodies with no idle control motor at all. With drive-by-wire, we don't have a idle control motor to worry about or deal with. We're doing all of the actual tuning for idle control relative to the throttle blade opening. That's the actual drive-by-wire throttle blade opening and spark timing. So what we've discussed in those previous tutorials about slow and fast path torque control is going to apply in here. Our slow path of torque control is our airflow movement via our throttle angle, in this case for drive-by-wire, and the fast path of torque control is going to be through spark timing feedback. And we want to set things up pretty specific for working in our idle control to have the best possible results. Let's go in here and take a look at a few things for setup and configuration. We're going to talk about how to get your idle dialed in extremely quick with drive-by-wire control. So we're going to move in from our fuel page here and let's jump across into our idle area here. So right now the engine's not running. We have key on, engine off. See, the engine RPM is 0. Our drive-by-wire throttle body is parking itself at its neutral spring position of 5% throttle blade opening. We're not taking control or doing anything. As soon as we start to crank over the engine, we're going to find that this throttle blade is going to command to what we call out for here in our base position table, as well as our startup offset, and we'll discuss how that all fits. And then when we actually get the engine to crank, fire, and run, it goes into what we're programming in here for a throttle target versus an actual throttle opening. This makes the tuning process super easy. When we were dealing with a stepper motor or a pulse width modulated motor, we were trying to figure out how much to open that idle control motor to allow a controlled vacuum leak to bring up or down the engine's torque to achieve our desired target speed that we specify here. Now with our drive-by-wire idle control, we're directly commanding the throttle angle to open a couple percent one way or another to achieve the airflow and the torque that we need to get our engine to idle where we want. It's super easy to set up and is definitely my favorite way to calibrate and tune any engine using a link. What I'm going to do is go in here to my mode, and we want to go and turn the system on and start to arm it. So in the mode, we have the option for open or closed loop control. We're going to choose closed loop, and we're going to set things up very specific so it doesn't have a lot of authority to move our throttle blade when we're in this closed loop operation. I'll go and discuss that a little bit further when we're setting up our idle actuator programming here. Let's go to closed loop and set this up, and we're going to go and click yes here for some of these default table values are going to start to populate. We have our idle base position. We have our idle target RPM. We're going to talk about these as well as our AC offset and startup offset and see how that fits into the routine. And we take a look here, we have our idle ignition control. Now we want to go in and set this off for right now. We're going to discuss why that is here in a little bit. We don't want the spark timing feedback yet. We want to establish what our idle base position or the throttle angle, where that needs to be at to get us in the ballpark of where we want our idle target to be at relative to engine coolant temperature. Now we do have a couple different things we need to set up in our idle control setup window. The actuator type we're going to set to E throttle because we're controlling everything with drive-by-wire. And then we have our speed lockout source, speed lockout value, APS TPS lockout, RPM lockout, and map lockout. Let's discuss these real quick. These are going to be thresholds that we have to go and exceed in order to go from a closed loop idle control into an open loop idle control, as well as moving from idle control to normal drive-by-wire throttle control that we're calling out in our drive-by-wire table here. So if we go back to drive-by-wire here, we have an E throttle target table. This is going to be when you're 1% throttle and higher, essentially, in your throttle command opening as you're starting to drive your engine and drive your vehicle. This is going to be what it runs for your desired throttle angle. It's going to assume you're starting to move. You're actually taking control over the engine. And when you drop below that threshold, it's going to kick back into your normal idle values in here and run your throttle blade to wherever it needs to be at. So that's the difference. It's going to be transitioning back and forth. So we need to set these thresholds here so it makes sense for our programming. So we typically want to have a speed lockout source. Right now it's set to driving wheel speed. You can define that whatever speed source you want to work with here, but this is going to tell the link where it wants to switch from closed to open loop and go from idle control into the normal throttle mapping control in our drive-by-wire. 1 to 2 mile per hour is pretty sufficient here. I'll leave it at 1 mile per hour, so that's good. APS TPS lockout. This is telling it where that threshold is going to be to transition from idle control to normal drive-by-wire throttle control. 1% is fine. I'm going to leave it at 1%. RPM lockout above target. That's going to say that the closed loop will turn off if we're 500 RPMs higher than whatever we command here for the idle target RPM table value at a given coolant temperature. Usually 500 to 800 RPM is what we want to place here. The map lockout. This is going to be depending on what your engine is pulling for vacuum when you're sitting on a warm idle. So I usually set this to kind of get started at something like 80 kPa. 80 kPa and higher, it kicks it out of closed loop in the idle control, switches it over to open loop. If you're idling at something like 20, 30 kPa, so you have mild cams, stock cams, you probably want to set this to something like 60 kPa, usually about 30 to 40 kPa higher than whatever the map pressure is registering and reading on a warm idle is what this setting should be set at. But we need to put some value in here to get things going with our idle control tuning. I'll set it at 80 for right now. Okay, so the next thing we have to worry about here is going to be our idle base position and our idle RPM target table. We want to set reasonable targets for our idle RPM. This is where we want our engine to idle at. The base position, in this case, is going to be what the throttle angle should be set at to maintain to a desired idle speed. So essentially, how much airflow we're coming in from the slow path of control to control the engine's torque. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.